This is my assignment 6.3 for numerical models. There are a few different types of kinetics and kinematics. Kinetics is the study of force involved in the movement of an object or body. The different kinds of kinetics are linear, which is force, gravity, mass and weight, and there is also angular kinetics, which is torque movements and levers. Kinematics is the study of motion or the change in position of an object or body. The different kinds of kinematics are linear, which is in the shape of a straight line, curvilinear, which is in the shape of a curve, angular or rotational, which is around an axis, and general, which is angular and rotational motion together. There are three different types of motion. The first is linear motion, which is also known as a translation, and this is where an athlete moves the same distance at the same time and in the same direction, and an example of this would link to a sprinter. Angular motion is rotation, and this takes place when the body or object moves along a curve. Projectiles are linked to only the forces, gravity and air resistance. A numerical model is the use of numbers or units to represent a sporting performance, and this is often done on a computer or it is software generated. There are a few issues with numerical models, and this can be things like cost. The equipment that is used is very advanced, meaning that it is also very expensive. Another issue is that the access that people have to the equipment, as the testing is mainly done in labs and only elite athletes and their coaches have access to these if they have the money and are able to test their performances. Scalar quantities only have magnitude or size, and the scalar quantities include distance, speed, time, power and energy, and they change when magnitude changes. There are 6 vectors, and they are displacement, velocity, acceleration, force, weight and momentum. They change when magnitude changes and when direction changes, or when both of these things change together at the same time. The speed of something tells you how fast it is moving, and speed can be measured by dividing distance by time. To find the average speed of something, you need to know the distance that it travelled and the time it took to complete that distance. The velocity of an object is its speed in a certain direction. Acceleration is the change in velocity, and if something accelerates, then the speed has changed, its direction has changed, or both of these things have changed together. Distance is the sum of all movements, regardless of their direction or its path, and this is the exact route that the athlete takes. And an example of this is when an athlete is running around a track, and what is measured is the distance of the track that they are running on. Displacement is the difference between an object or a body's final position and its initial position. For example, after an athlete has run 200 meters on a track, the displacement will be measured from the starting line, taking a direct route across the track and to the finishing line. An example of this that relates to basketball is when a player is jumping. When they jump, they might jump 4 meters in the air, and this means that their distance is 4 and their displacement is 4. However, when they land, their distance will be 8 meters, but their displacement will only be 0, and this is because they have landed where they first started their jump. This graph shows my results for a 20-meter sprint, and it shows the speed at which I got to each marker along the track. Sir Isaac Newton has 3 laws of motion, the first one being inertia, and this means that the body or object will have a reluctance to change its motion whether it is static or moving, and the state of motion can only be changed by another force being exerted onto it. An example of this is when a ball is being thrown to a player's teammate in a pass. When the ball is moving through the air, its state of motion won't change unless another force is applied to it. This force being applied will be the teammate catching the ball and stopping the ball from travelling any further through the air. The second law of motion is acceleration, and this law states that the acceleration of an object depends on the mass of the object and the amount of force that is applied to it, and it is how the velocity of an object or body changes when a force has been applied. This law depends on two different variables, the net force acting upon the object or body, and the mass of the object or body. When the amount of force is increased in the object, this causes the acceleration of the object to also increase, and when the mass of the object increases, the acceleration will decrease. An example of this is when a player is shooting a ball towards the net. The mass of the ball and the force applied to it will determine how far the ball will go and what direction it will go in. The third law of motion by Sir Isaac Newton is called action and reaction. This law states that if there is a force being applied to something, there will be an equal and opposite reaction force back. This law can apply to basketball when the player is bouncing the ball. When the player forces the ball towards the ground, the ball will bounce back up, and this is due to the ground reaction force, pushing the ball back towards the player's hand. If there was no reaction force, when the ball would hit the ground, it would not bounce back up towards the player. There are certain ways that cameras need to be set up during a biomechanics experiment, and this can take over an hour to get all of the equipment used into the correct positions. The camera settings need to be changed before the experiment is carried out. There needs to be a high frame rate so that there are lots of individual images to look at before deciding the best picture and the position of the body for the experiment to get the most accurate results. There needs to be a high sampling frequency as this is good for measuring motion. For the shutter speed of the camera, it is better to have it quite fast when analysing someone's performance of a skill, as this is a good way to see how the person can perform a certain skill, to see where they can improve. However, the downside of this is that due to the fast shutter speed, not a lot of light will be able to get into the shot as the shutter is moving too fast. The focus of the camera needs to be altered manually, as this gives more accuracy to the shot. Because if the focus was automatic, when someone is running, the camera won't be able to focus on the participant, as they are moving too fast for the camera to focus on them, and the focus will be on the background as it isn't moving and it is much easier for the camera to focus on. To focus the camera manually, you need to get someone to stand in the center point of the shot and zoom into the place where you want to measure the angle from, and make sure that the focus is on the body and not on the background so that it is easier to see where their body position is when looking back at the footage for the results. The methods of testing need to be consistent, which means that they need to be reliable and able to be tested and then retested more than once. They also need to be inter-researchable, research reliable. Another way of testing and measuring things is by framing a shot, and this is done so that researchers can look back at the footage and be able to measure the angles between the hip, knee and ankle. There are lots of methods that are used in biomechanics, and the main ones which are used to measure force and movement are by using force plates, which are used to measure the amount of power someone is using when they are doing a stationary jump, both without an arm swing and with an arm swing. Movement is measured by using a camera, and this is mainly used when people are running and the researchers are measuring the angle at the knee. Before testing, all of the equipment needs to be checked to make sure that it is all calibrated and works correctly and efficiently. Calibrating data is often done in 2D for coaches of school teams, as this is because they don't have the money or right facilities to access the 3D data. This is the results that we got from Brighton University, and I will be analysing this in my assignment 6.4.